Hello, hello. We're back for round three. Sorry about that. So we're gonna go ahead and solve for this when t is 5. So when t is 5, we're gonna plug this in to be 500 times 4 to the power of 5 over 3. Now that really doesn't have an automatic, simplification, I believe. I'll just type it in, but at this point, we could just type in the whole expression. So 500 times this 4 to the power of 5 over 3. And if it's population, I'm going to go ahead and round up and I'll get 5,040. So hopefully when you type that into the calculator, you get the same thing as well. Okay. All right, let's go ahead and do another example. A radioactive substance has a half-life of 10 hours. Initially, there are 200 grams. How much remains after 30 hours? Okay, so this one is giving us a bit more detail than we um, know what to do with. But let's just go with what we do know. We do know that at 200 grams, or no, that we started with 200 grams, excuse me. So we know y0 is equal to 200. Now, it says a radioactive substance has a half-life of 10 hours. So that means this substance will be half gone at 10 hours. So we have to work around getting this number. So let's go ahead and do that. We have 100 is equal to let me rewrite the formula just so I don't butcher anything by accident. 200 e to the k times t. But this is for that 100 for when that t is actually going to be 10. So we should go ahead and do that for when it's actually 10. So we can go ahead and isolate the k like we've done before. Divided by 200, we get 1 over 2, simplified. E to the k times 10. Take ln of both sides to get k times 10 and divide by 10. Now I'm writing it like this already because I know that I'm going to do that multiplication trick. So let's go ahead and plug it back in. We have y is equal to y0, we said 200. E to the ln of 1 over 2 times 1 over 10 times t, but I'm just going to go ahead and write on top here. I'm going to go ahead and sneak it in to where it's ln of 1 over 2 to the power of t over 10. That will cancel out, and you're left with 200 times 1/2 to the power of t over 10. And then they said how much remains after 30 hours. So let's go ahead and just plug in t to be 30. We're going to see right away that it's going to be a third. Give me a third. That's going to be 3. So 200 times 1 over 2 to the power of 3. It's going to be 1 out of 8. And then this probably doesn't have that pretty of a form, so I'm just going to go ahead and just type into the calculator. Oh, it does. Oof, I should have clocked that. My bad. But it's going to be 25. So 25 is left. Now, the only thing I will say here is a key indication of radioactivity is that it decays. So as the properties decrease, it should be less than 200 grams. If for some reason you ended up getting it to where it wasn't that, then we have a technical issue, right? Okay. All right. What else? I wanted to say something else because I thought about it in the middle of my explanation. You could also, I now look at this and I see that you could technically also simplify this a non-ln way. Because they're multiplying powers, you can technically just take it to the power of something. You can write ELN 1 over 2, all of which is to the power of t over 10. That would cancel out, and this, inside the parentheses, this expression can simplify to 1 over 2 to the power of t over 10. So just something to think about if you're worried about the whole ln procedure. All right, let's do this last application. So it says a cup of coffee at 90 degrees Celsius is placed in a room of 20 degrees Celsius. After 10 minutes, the coffee has cooled to 70 degrees Celsius. Find its temperature after 20 minutes. How many minutes will it take the cup to reach to 30 degrees Celsius? And for this, we're going to use Newton's law of cooling, which states that the time, or the temperature of the coffee, or of the item really, at time t is equal to the temperature of the room plus the initial temperature minus the temperature of the room times e to the power of k, some rate, times t. So let's go ahead and figure this out. Now we know that the initial temperature of the object, in this case the cup of coffee, is 90 degrees. And we know that the temperature of the room is 20 degrees. So our specific formula for this cup of coffee can be written as 20 plus parentheses 90 minus 20 e to the k times t. And then you could simplify this a little bit by doing 90 minus 20 to be 70 e to the k times t. Now, this isn't a complete formula because we need k, but we are given a tidbit. We're saying that after 10 minutes, the coffee temperature is 70 degrees. So that means we can mess with this a little bit. Let's go ahead and solve for that k. We get 70 is equal to 20 plus 70 e to the 10k. Subtract the 20 to get 50. 70 e to the 10k divided by 70 to get 5 over 7 is equal to e to the 10k. Take ln of both sides. Ln of 5 over 7 is equal to 10k. And then divide by 10. 1 over 10 ln 5 over 7 is equal to k. That makes our actual temperature function 20 plus 70 times 5 over 7, do that in parentheses, to the power of t over 10. I went ahead and skipped the simplification step this time around. Now, after getting this function, we're asked two things. First asked to find the temperature at 20 minutes, and then we're also asked how long until the cup reaches 30 degrees. So let's go ahead and first do the, here I'm gonna color code that actually. Let's do the first part where they ask me what's the temperature at 20 minutes? So that means T is equal to 20. So I'm going to write 20 plus 70 times 5 over 7 to the power of 2, since 20 divided by 10 is 2. So I'm just going to type that into my calculator. And I get 55.71 degrees Celsius. And that's my answer. Let me just I have it here. I might as well just check my formula sheet. Yeah, I mean my formula sheet, my answer sheet. Yes. All right, next one. How many minutes will it take the cup to reach 30 degrees? So this one is you're solving for t. So you're doing when t of something is equal to 30 degrees Celsius. So 30 degrees Celsius, or I shouldn't put that. We don't need to do the unit variable every time. is equal to 20 times 70 times 5 over 7 to the power of t over 10. So divide that out, we get 3 over 2. Or no, that's adding. So that's now multiplication. So we just subtract that, and we get 10. So 10 is equal to 75 over 7 t over 10. Divide by 70, we get 1 over 7 is equal to 5 over 7 t 10. And from here, you're going to do a technicality where you take the log, but of base 5 over 7. Wait. I don't think you can. No, you can't take logs with a fraction. Or actually, you could. Yeah. It's a little weird, but you could. Okay. So I'm gonna use this though because I'm just using my scientific calculator. We know that log base b of a can be done as log of a divided by log of b. So just to check that, I know log of 8 divided by log of 2 should be 3, and it is. Okay, cool. So let's go ahead and do that. I'll do, wait, wrong color. I'll do log base 5 over 7 of 1 over 7 is equal to t over 10, and then I'll just multiply that by 10. So 10 times log base 5 over 7, 1 over 7. So I'm going to type that into my calculator, and this I'm going to do live with you guys. We have 10 times log of 1 over 7 divided by log of 5 over 7. Oop. And then we're going to go ahead and just, after that, yeah, that's pretty much it. The whole log. Okay. Enter, and we get that the time it takes to reach 30 degrees is 57.83 minutes. Okay. So a little odd, but nothing too, out of the way. We can compare these just a little bit because we know that at 20 minutes it was 55. So if it is still cooling down, then it's supposed to take longer than 20 minutes, and it does. So it's not too weird. Similarly, we also know that at 10 it was 70. So we see that, 10, 70, 20, 55, and then a bit out of order, but 57, 30, it is decreasing over time. All right, that's going to wrap up these application problems and all of Unit 2 together. Sorry about it being in 3 parts. That's it's one of those things where if your mom or dad call you, you always answer. So that's the reason why I had to stop the video the second time. I apologize. But yeah, that's gonna wrap it up. I'll see you guys in the group work or in the worksheet video. Where's my mouse? Well, oh, it's over there. Okay. All right. Bye bye. Bye bye.